Hello there, I'm Thomas, Hatsios, German-American pilot flying the Boeing 787-900. Tonight's flight will be flying from Zurich International Airport, overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing, turn on the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments and explaining the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the vertical rate of climb and descent of the aircraft in tens, hundreds and thousands of feet per minute, or the steepness of the trigonometric angles in degrees you can climb and descend. We have also the artificial horizon with the pitch ladder in degrees and the bank angle in degrees, the altitude indicator, the ILS localizer, the horizontal localizer, and the vertical glide slope. The aircraft can follow using the ILS localizer receivers, the onboard receivers, antennas of the aircraft that receive the radio frequencies transmitted from the airports. We use for takeoff and for landing. So we are in the runway 14 of Zurich International Airport, Lszh in Switzerland. We're going to use this runway both for takeoff and for landing. So we're going to have the ILS localizer frequency transmitted from the radio antennas of the runway threshold, and it's going to give us an alignment with the runway magnetic north pole heading. We're going to set in the autopilot flight director system panel. So you're going to see how we're going to use the ILS localizer for approach and landing, the horizontal localizer and the vertical glide slope. We have also the ILS localizer crossbars, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode and 0 with the autopilot and the auto throttle, later on vertical navigation modes. We have also you can see here, so you can see the displays here. You can see the primary flight display and the navigation display. I will explain you how its system is working. You can see the tiller we use for nose wheel steering. You can make the aircraft turn in the ground in the left and right direction. You have directional control. As you can see here, the primary flight display, you can see the airspeed indicated. Over here, the airspeed selected from the autopilot flight director system panel, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute, the steepness of the trigonometric angles degrees you can set from the flight management. From the autopilot flight director system panel, the pitch ladder in degrees 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down, and the bank angle in degrees, the flight mode and 0 with the autopilot and the auto throttle, later vertical navigation modes. Γεια σου. Πήγαμε, αλλά θα γυρίσαμε και θα ξαναπάμε μετά. So you're gonna see also the navigation display. The navigation display that displays the horizontal, so the vertical profile of the aircraft as it flies. You can see the terrain and weather reflection from the weather radar. the terrain map with the airports. You can see the red, green and yellow display of the terrain in front of you and around you, and also the elevation you find above the ground level. You can see the terrain in front of you and make terrain avoidance. With red, green, yellow color, also with blue you can see the lakes and the rivers. You can see the red, the blue 4-letter code name, ICAO name of the airports. Θέλει να πάμε σε μια ώρα ακριβώς, πες του. Να κάτσει να ξεκουραστεί λίγο, άμα θέλει πες του να πάμε σε μια ώρα. Είπε σε μια ώρα ή τώρα? So you can see the navigation display that displays also the other aircraft that fly around you. Displayed with red color, we have an incoming aircraft very close to us, or right, they are in a far distance. We have the transponder, the ADSB and ADC transmitter receiver that transmits our frequency to other aircraft in the air traffic control and receives from other aircraft, and displays in the navigation display, and you can see the distance the other aircraft are located, the altitude difference from our aircraft, whether they climb or descend with respect to our aircraft. And also this calculates the velocity closing in between our aircraft and the other aircraft, and give us the TICA system, the traffic collision advisory system, the warnings in the navigation display, in the primary flight display. So we have over here the navigation display. You can see the displays the terrain map, and we're gonna see later the flight plan. We're gonna create also the engine indications here. You can see the left and the right engine indications. You can select here from the display, which is a touch screen. You have also the flight management computer. Over here you're gonna set up the flight plan and set the takeoff gross weight of the aircraft for this flight, and we have the mouse pad for that. To use the cursor, we have the autopilot flight director system panel. You can set the airspeed guidance, the autopilot engage and disengage, the auto throttle left and auto throttle right, engage and disengage the flight director, the LNAV and the VNAV, lateral navigation, vertical navigation, which is interconnected with the flight management computer guidance. When we select the flight plan, when we create the flight plan, you're gonna see we can turn on the autopilot and we'll follow the flight plan, the purple line, horizontally and vertically. We have also the heading guidance, the heading select, and the bank angle limit in flight, the vertical rate of climb descent of the aircraft in hundreds of feet per minute, and the altitude select and hold switch, the barometric altitude, and the word localizer in the approach for autoland. So you can see also some displays here. You can set up the barometric pressure in inches of mercury. With this switch we have it 29.92. You can set it lower or higher, and the minimums radio approach, the flight plan map, the range, the weather radar, the traffic and the terrain on the display. And the systems, we have the electric, hydraulic, pressurization, flight controls, landing gear. We're gonna see them later in the display in a digital format, and the checklist, we have digital checklist. You're gonna see also that. So you're gonna see how we're gonna use the flight controls to control the Boeing 787 flight control system. You're gonna see the joystick. So we'll make an explanation about all the systems. Before we're gonna make an engine start demonstration, we're gonna start flying the aircraft. I will set up the flight management computer. I will input all the data of the aircraft for this flight. That includes the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right weight in the center tank, and also the loads from the cargo and the passengers. The flight management computer calculates automatically every second, also when we fly and also before takeoff, the fuel on board and the fuel level. We burn fuel as we fly, so it shifts the center of gravity, so it calculates the center of gravity all the time before takeoff and during flight. It calculates that, and this calculates also the mean aerodynamic chord position of the forward wings is 23% for this flight. Of the Mach of the forward wings is the position where the maximum aerodynamic lift occurs. In the forward wings is also the position where the stall will begin. The airflow would become detached from the top surface of the wings as we fly. So you will see also that. So I will show you some about the aerodynamics of the aircraft, the wings, the flight controls, the Newton's physics, and the Bernoulli theory of fluid. So I'm gonna show you all these things. We use the takeoff gross weight and the main aerodynamic chord position in the flight management computer. Also the flaps for takeoff, we're gonna use 15 degrees of flaps, and this will give us a horizontal trim stabilizer. For takeoff, we're gonna trim the horizontal tail of the aircraft at 4.25 degrees, positive pitch, nose pitch attitude. So we're gonna pitch up the nose of the aircraft in flight by trimming up the horizontal tail in flight before takeoff and during flight. We can trim it either manually or automatically using the autopilot flight director system panel and the auto throttle. We have the auto trim function from the fly-by-wire system of the aircraft, and this is a fly-by-wire aircraft. It has flight control computers and the flight management computer to set up the flight controls in flight, the center of gravity calculations, the fuel on board calculations, and other stuff. This aerodynamic lift also calculations on whether we use flaps or no flaps as we fly, landing gear and speed brakes. So we make every calculation. We can do all this manually and automatically, as I told you. So we have also the horizontal tail trim stabilizer. As I told you, we can trim the horizontal tail of the aircraft either manually or automatically. So I'll talk to you about that. I'll keep talking about the flight plan. Maybe later. We're gonna use the takeoff runway. We are in the Zurich International Airport, Lszh, and we're gonna use runway 14. The runway length, the runway slope, the wind direction, the speed, the barometric pressure, the density of the air, the temperature of the air, and the runway conditions. If we decide dry or wet, the flight management is gonna make calculations about the takeoff speeds V1, V-rotate, and V2. We're gonna insert the seats so that we can departure waypoints and fixes for the initial climb of the aircraft. And the top of glide, the cruise level 25, 26, 27, 28, 29, 30,000 feet above the sea level. Then we're gonna transverse through some waypoints in flight. You're gonna see them in the navigation display. Then we're gonna have the top of descent, approach, and descent to the stars. The stars are the terminal arrival waypoints and fixes for the terminal approach of the aircraft. We're gonna descend from the cruise level, like 30,000 feet, back to 7,000 and 6,000 feet above the sea level and above the airport elevation. And we're gonna have the alignment of the aircraft with the runway using the stars for alignment, and also the ILS localizer. We're gonna have the instrument landing system. As I told you, the ILS localizer frequency tuned for this runway. 14 ILS localizer in Zurich International Airport in Switzerland, and the magnetic North Pole heading instead of the geographic North Pole heading for alignment 136 degrees magnetic North Pole. So we're gonna be aligned with the horizontal localizer and vertical glide slope at the NS frequency from the runway for approach and landing. We're gonna have the flap set to 25-30 degrees for approach and landing, and also a pitch attitude of 9 degrees like in takeoff, and also an airspeed 160 or 170 knots, and the landing gear extended. So this is all we have right now. I'm gonna show you the outside view of the aircraft and talk to you about Newton's physics, aeronautical and aerospace engineering. So I will talk to you how the flight controls also work. So you can see the wings hold the aircraft weight as we fly, as we develop an airspeed from the thrust from the engines. Also you can see we have the lateral axis from wingtip to wingtip, the longitudinal from the nose to the tail of the aircraft over here, and the vertical through the center of gravity of the aircraft, where is also the main aerodynamic chord of the forward wings position, located 23% of the Mach for this flight, is where the maximum aerodynamic lift occurs in the forward wings in the top surface as we fly, and also the center of gravity through here, and the fuel on board in the left and right wing tank, the center tank, and also where the stall will begin, the top surface of the wings airflow becomes detached, and there we have the stall. So we need to avoid the stall. I will talk to you about later. So you can see the flight controls here, the control the side stick. You can see we can control the tail for climb descent, also make turns left and turns right, the rudder pedals. So we can climb a descent, make turns to the left and turns to the right. So you can see also we have the horizontal trim stabilizer and the elevator. We can trim the horizontal tail during flight up and down to balance the aircraft. So you're gonna see how we're gonna trim it. We have the thrust from the engines, and we have the wings of the aircraft. You can see the bottom surface of the wings is more flat, and we have the curvature from the flaps extended. Also, as we fly, we have an angle of attack that is positive, so the airflow is moving much lower below the wings. We have higher pressure, which pressurizes the wings and the weight of the aircraft up into the air as we fly, using the Bernoulli theory of fluids. And then you can see the top surface of the wings is more curved, so using the Bernoulli theory of fluids, the airflow is moving much faster above the wings, which sucks the aircraft wings up into the air. We have lower pressure above the wings. So this is a basic aerodynamics explanation about the flight controls and the wings of the aircraft and the thrust from the engines. I will show you the flight controls, also the horizontal trim stabilizer over here. You can see the control column we use for moving the elevator up and down like this. So we can climb and descend like this. You can see we have also the ailerons and the spoilers in the control wheel. We make turns left and turns to the right using the ailerons and the spoilers like this, left and right, actually left and right like this. So we have also the rudder pedals again, right and left like this, or left and right. So you can see the rudder moving now, right and left direction. So we use all these flight controls here for directional control in flight. I will show you also the horizontal trim stabilizer, which is part of the flight control system. We can trim the horizontal tail of the aircraft down or up, and we can pitch up the nose of the aircraft, pitch up like this, nose pitch up and nose pitch down like this. So you can see the elevator trim. Elevator trim, left click down, right click up. So this is the elevator trim of the aircraft. Very important, the autopilot also disengages and the head-up declutter. So this is 3 switches you need to use. We have also the horizontal trim stabilizer position over here, nose down or nose up, the flaps extended, the rudder trim position. You can see the engines also, the outflow valves from the cabin pressurization. We have also the horizontal tail trim. So the horizontal tail trim, you see the tail of the aircraft moving up and down, pitching up the nose of the aircraft. Θες να πάμε σε 40 λεπτά. Είναι πολύ εύκολο, πάμε και τις παίρνουμε αμέσως, δεν είναι τίποτα φωτογραφίες. Το CVS είναι όλη τη μέρα ανοιχτό. Πόσο? 40 ή 50 λεπτά. So you can see all these controls here. We have the thrust levers also, the indications from the engines, the flaps, retract and extend. and the speed brakes extend and retract, the thrust levers. So I will make the flight controls lesson a little bit here. So you can see here we can climb and we can descend like this. The aircraft make turns to the left and turns to the right. So you can see the side stick deflection is proportional to the yoke deflection as we're gonna be flying. So we have to set up over here, as you see, the thrust levers also moving forward and aft. Indications from the engines over here. So you can see also the outside view of the flight controls, like this. So we can climb and descend, make turns to the left and make turns to the right. So we'll set up the flight management computer very quickly. Control quadrant over here. And so we have the index. You can set up any value, any mode you want. Identity, Boeing 787. Position, the reference airport, Lszh in Switzerland, and the GPS position. Index over here. Performance, the route from this airport, Lszh, Zurich International Airport in Switzerland, back in Lszh in Switzerland. Runway 14 over here. Departures and arrivals. So we have select runway 14, the seats, the other instrument departure waypoints and fixes with alpha, and then arrival. ILS 14, we can select either one, Trans-Amity, Trans-Negria 1 alpha, and we have the flight plan almost complete. We need to cancel a discontinuity here and select initialize the fuel, zero fuel weight plus fuel on board, gross weight for takeoff plus the reserves 5%, cruising altitude 25,300 feet, cost index 100%, and we have to execute to activate the flight plan. And we have the Mazda here, the purple color. The flight plan is ready from takeoff, the first waypoint, second, third. In the altitudes we have to cross through Zui 6,000 feet, 320 knots, Negria 302 knots, flight level 22,100. Then we descend Matif back for approach and landing, Amiki Zui Z8701, waypoint by waypoint, DRA CI14, Osnem, runway 14, approach and landing, 140 knots. So this is the flight plan. We use also 15 degrees of takeoff flaps over here, and the center of gravity calculated automatically, and we have takeoff speed V1, we rotate V2. So initialize, we can use also fix, hold, departure arrival, LNAV, VNAV, progress, navigation radio, we tune the ILS localizer. So this is the flight plan. You can see displayed here. So I was talking about the horizontal trim stabilizer. You can see we have the auto trim disconnect switch for all Boeing 737, 747, 757, 767, 777 and 787. We open from normal to cutoff and use the alternate pitch trim over here. And you can see nose up and nose down, the horizontal trim stabilizer. Also you have the parking brakes here. In case you have a failure of the hydraulics of the L2 and R2 system, the hydraulic system here, you use only the manual, you use the auto trim function, so you use the manual trim here. So I told you we have the flaps also. Position here, how many degrees you want, 25, 30, 1, 5, 10 degrees, 15 degrees. You can see how many degrees you set them. The thrust levers, the auto throttle disconnect switch over here. the speed brakes over here, the fuel control left and right engine. We're gonna turn off the fuel layer. The fire extinguisher left and right pull out and switch, the transporter, fire extinguisher for the left and right engine, the rudder trim, radio management panel, radio communication panel, landing gear over here, external retract, standby display, alternate gear, lock override, and the auto brake. We have also here you can use over here the display. You can see the N1, which is the low speed starter, soft low pressure compressor and turbine of the turbofan with sensing the left and right, the exhaust gas temperature per engine. So we have 19.8% idle, 99.6 maximum takeoff thrust limit, green, red and yellow. The N2, which is the high speed starter, soft high pressure compressor and turbine of the turbofan with engine, the left and right fuel flow per engine per 1000 kilograms pounds, oil pressure, oil temperature, oil quantity, and the vibration of the two stages of the engine, gross weight for takeoff, and the outflow valves, the cabin pressurization, cabin altitude right now is 1400, rate of climate descent, differential pressure is going to be 7.8 to 8 psi, the flaps position, and we have also the flight plan here created. You can see display in the navigation display. We have the runways also we use for takeoff and for landing. So this is the flight plan, the terrain, the indications. We're gonna use also some indications here from the autopilot and flight director system panel. So we're gonna use, you can see the autopilot over here, auto throttle left and right, flight director, LNAV and VNAV. So we can turn off flight director, all modes disarm. We need the flight director over here on to arm any mode in the autopilot like the LNAV or the VNAV. Set up the airspeed guidance. So this is gonna be the airspeed like for flying. Flight level change, autopilot engaging, engage, flight level change, auto throttle, climb continues, bank angle limit, heading. We're gonna set the heading for the runway. We're gonna use for takeoff and for landing. 136 degrees for this flight. Altitude also. Altitude limit for altitude 35,000, 300 feet. Vertical speed, you can descend like this. This is the minus sign display, or you can climb, you can level off, you can zeros. So we have a few more systems. You see now everything is displayed same like in the autopilot display over here. The LNAV over here, target airspeed 253, target altitude 35,000, 300. The purple also the vertical and the horizontal navigation display. So we have a few things to see in the overhead panel over here. We have the APU. We're gonna start the APU to start the engines. The battery, the contactor is 120 to 100 volts, 400 Hz frequency, left and right IDZ. The primary flight control computers over here at auto position. The heading reference, the air data computer, pitot static, pitot dynamic, GPS receivers, airspeed and altitude, laser gyroscopes, and magnetic north pole. All these are in this computer. Flight control surfaces, also geographic north pole, Towny power, FT door, passenger oxygen over here, window heat, rammer turbine, standby backup hydraulic power from the rammer turbine. We have to turn off the primary and demand pumps, left and right engine driving. So you see what happens. We turn back on, then to the auto. We have the electric also. We have the wing and engine RDIs over here, on and auto. We have the lighting system of the aircraft and the windshield wipers. You can see the recorders over here, the fire, cargo and APU fire, the electronic and control here for the engine, normal and alternate mode, and the auto start. We're gonna use the auto start to start the engine's loader. There's two switches. We can dump some fuel to lose weight and make an emergency landing. Also we have the left and right wing fuel tank, the center tank, the fuel booster pumps, The crossfeed valve, if we turn it on, can feed either engine with either pump or either tank and balance the fuel also between the left and right wing. So we have all these pumps. Turn off the crossfeed, we don't need. We have also pressurizer from left and right engine, the packs and the ventilation, oxygen regulation, and the cabin pressurization. Use the outflow valves for climb and descent. In the manual mode, normal and alternator, or use the auto. We don't have to do anything. So now you will see everything you see in the overhead panel. You will see in the displays. So we have a few more minutes left. So you're gonna see the digital format of all the systems. You see hydraulic, APU, oxygen, and liquid cooling over here. The electric left and right engine, IDG, the APU is running. The battery voltage over here, 31 volts, and the average. So we have the generator contactors on, hydraulics left and right, engine driven, electric C1 and C2, where the hydraulic fluid goes, which system use hydraulic power. The fuel on board, left and right wing, fuel tank, the center tank, how much fuel we have, 11,000, 11,000, 11,000, 34,900. The minimum fuel temperature in flight, you can see minus 37 degrees Celsius, so we need to heat the fuel all the time. This is done automatically using the FAREX. The full authority is electronic control computers for the engines that control all the indications here from the engines that you see left and right engine, and also the fuel supply and the circulation of fuel to the engines for heating up the fuel in flight and cooling down the engines. So we have low and high pressure fuel valve left and right engine. The crossfeed valve is off, but if we turn it on, it can feed either engine with either pump or either tank and balance the fuel from the left and right wing. The APU is fed from the left wing using the DC motor. The air also, you can see the packs and the oxygen regulation and the temperature control. The doors are closed, the cabin can be pressurized. The gear, you can see the temperature of the line, the gear and the brakes. The flight controls over here. So we have the flight controls, move all flight control surfaces like this. You can see, you can climb, you can descend, use the tail, the rudder pedals. Everything is working normally over here using the flight controls like this. We have also the FS display, maintenance, system display, circuit breakers, digital maintenance, and also we have the checklist over here and the normal menu, what to do before takeoff, after takeoff, taxi, approach and landing. And we go back in the navigation display like this, and we need to start the engines. I'm gonna start over here the lights, turn on the lights. So I'm gonna make an engine start demonstration now, then I'm gonna make a complete flight from takeoff, climb, cruise, descent, approach and landing. So stay with me until the end part of the video. So you're gonna see, I'm gonna restart the engines right now. Turn both off fuel control, left and right. So you will see all the amber indications right here. The engines are shutting down. And we need to restart them. Restart the aircraft. So we turn on the auto start system over here, both left and right engine. So you see the amber indications here in the overhead panel. So you will see the pressure of the engine increase very rapidly. Actually it's from the APU right now. It's been fed up with pressurizer. So we need to start the fuel flow to the left and the right engine like this. You will see the auto start is kicking in. Above 20% and 2 we can start the fuel flow to the engine. So now we are 28, 29, 30% of the N2 stage of the engine. You can see the engines are kicking in. Start rotating. We're gonna have also the amber indications going off, because we're gonna have the systems working as the engines increase in power. So we have running both engines. We can go now for takeoff. So we use flaps over here, 15 degrees, 5 degrees for flaps, and we're gonna taxi to the runway. So parking brakes off like this, advance the thrust levers forward, and we taxi to the runway. So the runway is open for us. We take the clearance from the air traffic control. We can taxi using the tiller over here, aligned with the runway heading. So we advance the thrust levers to full takeoff power like this. We are aligned with the runway heading. So we have 90 knots, 100 knots, 120, V1, we rotate slightly. Use the rudder pedal for align with the runway heading. We have some sideway. So we climb, we have the positive climb. After takeoff, picks up a little bit. We keep climbing. Landing gear up over here. So we keep climbing. And we have 18 more minutes for this flight to complete for this video. So you can see here we have the airspeed indicated 180 knots. The pitch altitude 20 degrees. So the stall speed, we need to avoid yellow and red indications. 5,000 feet above the sea, 5,000 feet per minute the rate of climb. You can see here the indication from the engine stages also. So mostly important the airspeed. Also how far above we are from the terrain. The aircraft right now is like 4,000 feet above the terrain, displayed with green. Also you can see, if we look a little bit further, you will see also the indications from the terrain further away from you, red, green and yellow. And now the flight plan with Mazzera with purple color. So we're gonna have over here the outside view of the aircraft as we are departing the Zurich, Switzerland, and we're gonna come back later. So we need to start the turn. You can see the Switzerland here. Very beautiful view of the Switzerland, the lakes over here, and the Swiss Alps. And we have the Boeing 787. We take the turn right now. So we need to align with the flight plan over here as we're making the turn. Keep climbing. Use a little bit less, having the display of the flight plan here. So we keep climbing. So we decrease actually, retract the flaps. To increase the airspeed, if we can a little bit increase. So this is the view of the cockpit after takeoff of the Boeing 787. All the indications also as we keep climbing. Perhaps we need to increase the airspeed. Retract all the flaps. So we're gonna make a turn like this. So we have the magnificent view of the Switzerland over here, the Swiss Alps, and the lakes. Also we're gonna fly over Germany, my homeland, the Bayern Munich over here, and the France, and we have also the Italy behind us, and the Swiss Alps, the Switzerland. So we keep crossing 20,000 feet, 167 knots, the terrain, the flight line, and the waypoints we have to cross through. You see one by one. The distance 23.9, 0.8, 0.7 nautical miles. Now in front of us we need to go through these waypoints, also the engines indication, autopilot flight director system panel indications. We have a couple of aircraft in front of us. Head-up display over here. So we have a very beautiful view, the lake, the Germany, Bayern Munich in front of us. So we keep climbing a little bit more, and we're gonna make a turn now. We start turning back to the airport over here. We have about 12 more minutes for this flight. As we keep turning, we're gonna be having also the vapors from, you can see the flight plan we leave behind, and we need to take the turn now like this to go back into the airport. So we cross through the lakes here, the Switzerland frozen beautiful lakes, and now we have the view of the aircraft as we're flying. Keep climbing a little bit more. And make a turn with also with the right pedal. Use the right pedal to make a steeper turn with a lower airspeed. Right now we're very close also to the stall speed, as you can see, this margin. So we need to be aligned again with these lines here for approach and landing. So we are leveling off here. You can see we can hand the off. We can hold the hands off and keep flying straight and level like this. You can look at the view of the cockpit at cruising level. So here we are cruising right now, and we need to climb a little bit more further up. So we have the beautiful view, the frozen vapors again. As you can see, we have the frozen vapors and a little bit star sign, the galaxy. We have some stars over here displayed because it's getting more night in the higher altitude. And we need like 7 more minutes to go back to the airport. So we're gonna make a turn here and we start descending back to the airport, cross 27,000 feet. Idle thrust also. Flaps are retracted fully. A little bit more thrust needed. Maybe full thrust. Keep having the chemtrails here, the galaxy. Also view. Need to descend. I'm gonna keep pitching down the aircraft, and we have 7 more minutes left for this video to end. Speed brakes extended. Keep having the chemtrails like this. Need to hold down the elevator and pitch trim the aircraft tail a little bit down. Keep descending. So we need to descend over here from this altitude back to the airport elevation and transverse through some waypoints here that you can see. We need to make a small turn out to the left to align with the flight plan here. Use a little bit more thrust. "19,000 feet. Keep descending. So we are at 19,000 feet right now. We have also the star sign now, the night sky. Over here the galaxy view. It's getting more night. So you can see we have to cross through these waypoints over here as we are descending back to the airport elevation. They are the same like this we have here in the flight plan store. A little bit less thrust. We need to start the turn now for approach. And landing, as you can see, we are 13,000 feet. We have on the left side the airport. Use a little bit left rudder as we make the turn here. Keep descending. So we have a few more minutes left for the approach and landing. We're gonna be aligned off the runway shedding. As you can see, there's a little bit left rudder again. And we have the runway in front of us. Long final approach over here. So we're going to be having also the landing gear now and some flaps extended for the approach. So you can see we're going to be having this nicer view for approach and landing. We need to increase the rate of descent a little bit, higher rate of descent, because we left a little bit higher. Also use a little bit more flaps. So you can see the runway here, use a little bit more engine power now. We have the thrust up and a little bit more pitstream. You can see we are descending for approach over here. We have also the Lszh localizer, the display. You can see the flaps and the localizer, the needle, we are almost aligned. Also the horizontal and vertical over here, the navigation display. We have almost full alignment with the Lszh localizer, a little bit, maybe less thrust. We can see also the head-up display, the runway here, and the indications. Need to approach for landing to this runway. So a little bit more thrust. We have full flaps, landing gear extended, keep the airspeed, and we have some side wind. We need all the flight controls when we have side wind to combat the side wind align with the runway shedding, like the rudder pedals and the ailerons and the spoilers. This is our side wing approach. We have also some gust, wind, and this makes more difficult the approach. We need to add some thrust from time to time. Makes the aircraft lose its heading, and we have to regain the heading. So add some thrust again. Now we are in the final approach and landing. We are approaching for the flare of the aircraft actually. We're gonna be aligned for the runway heading and the flare also. So we are very close for the flare here. Idle thrust, and we have aligned with the runway and the flare. As you can see, flare and touchdown, very beautiful flare and touchdown of the aircraft. And we use parking brakes here. Successful landing. Idle thrust also, and thrust reverse, full thrust reverse, and use a little bit rudder to align with the runway heading. So you can see we have full a little bit left rudder now to align with the center line, a little bit right rudder later. So you can see we just landed. We made a very beautiful landing over here in the runway. We are in the center line. You can see the indications here. We have the nose wheel is perfectly safe. There is no breakage of any part of the aircraft, as you can see. The aircraft can be fly again. You can see the landing gear behind all the wheels over here. There is no breakage of any wheel or of any tire from the landing or the nose wheel over here in the front. You can see again, you can examine that. There is no breakage of any part of the landing gear or any tire. You can see the nose wheel, the tires, and the metal parts are safe. So we can use the aircraft again for one more time, like this. So you can see the aircraft is safe. We can use it one more time. We can see also the runway. It just landed over here. We have plenty of runway for slowing down. You can see we have the thrust reverse open here. The thrust reverses this door. We need to close over here, so you can apply idle thrust and thrust reversers forward. You will see the thrust reverse close. So this is the cockpit after landing over here. Everything is normal. All indications. You can see the flight controls keep working, and the engines indications keep normal. We can use the aircraft again one more time. So you see the thrust reverses, how we deploy them over here, and how we retract. Over here, this handle forward, like this, it closes down. So that was all for this flight tonight. I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight, flight from Zurich International Airport back to Zurich International Airport. Thank you very much for listening. I'll see you next time. Bye bye. We can also taxi the aircraft here if we need. So we see again the nose wheel. Everything's safe, the landing gear, the walk around of the aircraft. You can see the nose wheel here and the landing gear here. There's no brake assist. Also the other side here, the wheels in this side also are safe. So I'll see you next time. Thank you very much for watching me. Bye bye. We just made a successful landing in the Zurich International Airport, the Lszh in Switzerland. Bye bye. Bye.